Hi, everyone, and welcome back to another episode. In today's episode, we are covering one of my favorite topics, containers and container security. Without further ado, let's dive right into the topic. So, what are containers? Containers are lightweight, standalone executable packages or software packages that includes everything that we need to run our applications. So that means this includes the code, the runtime, libraries, and all the other system tools that we need. I always like to give this analogy of a traveler and say, think of your home, which typically is like your operating system or server that has everything that you typically will use and run and so forth. Sometimes there are things that you don't even need. Like it's not every day that you will use your blender in the kitchen, but in some days you'll need it. So containers work in this way where I say you think of yourself as the traveler. When you travel, you only grab the things that you need. So it might be your toothbrush. It might be a pair of jeans that you need. It might be a pair of sunglasses because you're going to somewhere tropical, so forth. So containers are basically you grabbing the things that you need only for that particular thing to work. So those means that means the libraries, the code and all the other things that you need to make this application work. That said, containers originated from Linux chroot. We will talk about this briefly in the next slide. And what I'm going to do is just kind of walk through the Linux file structure just to explain what the Linux chroot works and how that evolved into the Linux containers and then eventually getting popularized by Docker. And today we see people running Kubernetes as one of the biggest ones that is out there. And we'll cover all these as we kind of go through this. So that said, at the simplest level, containers provide a way of creating this isolated environment that we call a sandbox where applications and their dependencies can live. So just like I said, as a traveler, you carry everything you need only in, say, your carry-on baggage or your checked baggage for just that purpose of that travel. I put it that way, as you call it. So I did mention Linux chroot. So Linux chroot, as we can, let's backtrack a little bit and talk about Linux. So Linux in general, one of the things that we typically are concerned about is file systems and how they work. So in your typical Linux directories, you have your root directory, then you have your bin, etc, home, and user folders. In Linux chroot, you ideally are creating this fake root environment where you have the same kinds of files, the bin directories, etc, home, user, and so forth. The only difference is that in this environment, you can think of it as a jail where you can never escape. Well, there's some jails you can escape, I guess. But think of it as a jail you can never escape within your environment that creates this fake root directory as well, again, that contains everything else that you need. So in a typical container environment, you're grabbing everything that you need, which includes the packages and so forth, just to run that application that you're running. So anyway, that said, why do we use containers? One of the first things is consistency. When we use containers, we're ensuring that our applications run the same. So when we package an application into a container, they run basically the same everywhere. So I'm not going to package an application for you and it will run differently on your machine and so forth. Not unless you've made some modifications to that container. Once I've already deployed it, you kind of redeploy it and so forth with some changes. That's it. But they provide us a way to run applications consistently across different platforms. Resource efficiency. We're sharing the host and operating system kernels resources. So it gives us this efficiency to run them with the minimal overhead that typical applications will require in terms of like having access to directly to the host operating system and so forth. Simplified deployment. Containers are super easy to deploy. So once we package applications with all their dependencies, we can guarantee that, as I mentioned in that first bullet point, consistency, they work the same across different places. So we're not worried about you having a different version of the application. If I've packaged that same application for you, they typically will work the same. So it makes it simple to deploy. We don't worry about what operating system it works on once we've packaged it and so forth and all of that. And then we can talk about scalability. So with containers, it provides us the ability to either scale down or scale up our applications depending on what we're trying to do. So we can add functionality as needed. We can take away functionalities and so forth as needed. And it makes it easier for us to be highly scalable in our environment. That said, one of the things that I want to talk about is the difference between containers and virtual machines. At a high level, they look the same and feel the same and sound the same. But the main thing that I want to highlight here is with virtual machines, if you look at the layers, let's start from the hardware layer. So you have a hardware, you have an operating system that's running, say whether it's a Linux server or a Windows server, and then you have a hypervisor that provides you the ability to run virtual machines. So in this diagram here, as you go up, is from bottom to up. We have we have a hardware, we have the host OS, we have a hypervisor that allows us to run VMs, which is virtual machines, and so forth. Now, on top of those virtual machines, what we do is we run applications. So this virtual machine could be a Linux virtual machine that's running a web server. This could be a virtual machine that's running Windows and running an Exchange server or Active Directory server or anything like that. And on top of these, we have our applications. Now, when we come to the container part, it's almost the same thing with the exception of the things that we're trading here. Instead of a hypervisor, we're trading that for a container daemon. So in this case, I just said Docker, which is like sort of like the abstraction layer, the middleware that enables us to run containers. Now, if you look at both diagrams, the difference here, as you can see, is rather than running on a virtual machine, we actually are running applications within containers. So we can package a container and that container contains an application that we're running. So in this case, we're leveraging the operating system versus as actually leveraging, say, an entire VM and so forth. So as you can see, that's where the differences come. They almost seem very similar, but in many ways, if we're thinking about the word virtual, they're all virtual, if you want to call it that, but they do function differently and so forth. So just wanted to highlight that part. And what are some of the key components of container technology? So we can talk about container images. So what are the images? Container images are ideally what we call the lightweight standalone executable package that once we have packaged everything we need, that's what we call a container image. So that image is typically what we put everything together and say, hey, this is my container image. Now I need you to run that in a container runtime environment. That said, moving on to our next terminology, which is the container runtime, that's the software that actually runs and manages the container. So if you look back here in our architecture diagram, this is where that container daemon would be, or runtime would be. So here we have Docker. In some instances, we have Kubernetes and so forth. So just going back to this. And then we do have something called a container orchestration tool, which ideally manages, scales, and deploys containerized applications. So Kubernetes falls primarily under the container orchestration. So just like the name implies, in an orchestration, think of Kubernetes as the handler or the choir master, if you want to call it. That's basically saying, hey, you do this, you do that. This is when I want to deploy this container. This is when I want this to be removed and outdated and so forth. All the things, update this container, all that. So it's how we manage and scale and deploy containers applications using Kubernetes. So Kubernetes will fall under the container orchestration. So the orchestration just manages everything for you in a much more larger environment. So since we're talking about some container terminology and so forth, one of the things that I want to cover is base images versus child images. Many times when you build containers and you build off your applications and so forth, there's the idea of what we call the base images. So the base images are typically what you get to build on. There's some images that are already out there, then rather than you even doing all the legwork, you just basically build on top of them and add what you need and so forth. So those are typically called base images. And then obviously whatever you build on top of those, we tend to call them the child images that adds your own kind of functionality and so forth. Most images you'll likely have will be child images because you're pretty much building off like your base images and so forth. So I just wanted to highlight that as well. Now, one of the things that we do want to cover actually is these are just a list of some of the popular containerization platforms. We have Docker. This is most widely used platform for containerization. And we do have Kubernetes, also leading orchestration tool. And we have Podman and then OpenShift as well. So just want to highlight those. What is the container lifecycle? Typically, we build images, we store those images, we deploy them as containers, and then we manage and scale. So when we build images, this is where we're creating the container image, say from a Docker file or something else. And we're ideally saying this is the packages we want to use, this is the versions, this is the commands, all of those things. We'll cover that in our demo in the end, but I just want to highlight that for now. So we typically build our images, we store them, whether it's using our local registries or hubs, as in this case, we have Docker Hub. So the difference between a local registry is you are managing it privately. And in Docker Hub, this is more like internet based. And I'm saying internet based only because it may not exist locally on that particular server that you're managing, but it could be on a different server, even within your network and so forth. And they're private registries because then they contain images that are only your images that you've created. So they're custom images. I always like to give the analogy and say, think of it like open source and proprietary software. So in private registries, you have your containers that you built and so forth. And in like the hubs and so forth, they tend to be public images that you can also pull, which are like base images that you can build off of and so forth. So just wanted to highlight that. And then we deploy containers. Obviously, we deploy our container instances as images, and then we manage and scale. And the manage and scale, this is where we either decide what we want to do, whether it's add functionality and so forth, or remove functionality, or having our own containerized environment where there are networks within networks of itself, like container networks and so forth. So managing and scaling can be, as much as it's one of the big things within containers, can also actually be one of the challenges that we tend to face when it comes to containers. So that said, let's get to the best part, container security best practices. So you always ensure your container images are secure. That means we're running libraries that are secure. We're looking at libraries that are free of vulnerabilities or known vulnerabilities and so forth when we package our applications or container images. And we also need to limit container privileges. What can the containers do within your environment? Who has access control to those containers and so forth? And the biggest thing here is many times you certainly do not want to run containers with highly privileged users or user access. And this is what we're talking about here when we say limit container privileges, as in those users that are running those container images should be users that are created for those container images versus say running this with your root user and so forth. And then obviously we talked about implementing access controls. Within these two are kind of related in a way, assuming that your containers get compromised, you want to have like the least access or limited access to your other resources within your environment and so forth. So you limit what containers have access to. Most of the time, that means we tend to segregate container networks, which I'm talking about in the fourth bullet here. Those containers should live in their own segment. So we create a network segment that those containers live in so they can access and talk to each other only versus having to talk to other resources within your environment or only needed access. And those accesses are restricted and so forth. And then obviously securing your container runtimes as well. One of the other things that we can talk about is automating vulnerability scanning. Containers, when we start to talk about containers, we are looking at infrastructure as a code a lot. And a lot of these automated scanning will help us, whether it's static analysis testing. There are many tools out there. Some of them, I think the popular one is Aqua. Aqua is pretty well known for testing container security. There's Trivy, which is open source and so forth. And there's other tools that you can use to do your vulnerability management for containers. So you also do want to regularly audit your container environment, which means checking against all these other things that we mentioned. Are your product teams deploying containers securely? Are they ensuring that they're limiting container privileges and so forth? Like audit will basically catch all of these things or help you catch all of these things or help you manage these things in the long run. And reducing the attack surface, many of these kind of fall under that, as in if we do have a container environment that's segregated, we're reducing the likelihood of an attacker or a malicious actor exploiting those vulnerabilities in those container environments and escaping that into the actual operating system or host system and so forth, or host networks and so forth. So reducing the attack surface is always essential, which is limit the access that it has, segregate it, make sure it's within its own sandbox that it should be, and running in those sandboxes. And then updating and patching your systems regularly. This is typical of any cybersecurity practice. Containers do require patching and update. So think of all the libraries that we've packaged, ideally every once in a while, the vulnerabilities that are found within those libraries. So we need to ensure that we can update those packages and make sure we're running the most up-to-date ones and so forth. And one of the biggest things, or the last thing I'll mention here, is securing your registries. We talked about registries in our previous slide, where we mentioned in some registries, they're public registries, so you can find other images that people have built, and you can find base images that people have built that you build on top of. Now, in this particular one, when we talk about securing your registries, remember your registries contain all your images. So if you don't secure this and a malicious actor has access to these, they can ideally modify all your base images. So think of all your base images being the ones that your product teams run off. So any product team wants to deploy some containers, they come in and then they grab those base images from your registry. So if you don't secure your registries and those images are compromised, you can really like have this supply chain issue where all the base images that people build off are already compromised in many ways. So securing your registries are essential. I can't highlight that any further. Now, what do we typically use containers for? Like many of the use cases differ, but these are some of the main ones that we've seen containers being used for. A lot of microservices we run using containers. So we break applications into smallable, manageable services. Many people automate their components of their CI/CD build pipelines and for testing and deployment and use containers for those functionalities. In our DevOps environment, this enhances collaboration between development teams or product teams and operational teams. And then a lot of times in cloud native applications, we can build and run scalable applications within our modern dynamic environments. What are some of the challenges when it comes to containers or container use within our environments? Well, obviously I mentioned this briefly earlier, orchestration complexity. So how do we manage these large numbers of containers that we can deploy within our environment? The idea that we can deploy containers so easily and almost anyone can deploy containers or their own containers makes it like a nightmare in terms of how we inventory everything that's running within our environments. Like this is a very real problem out there. So be mindful. Orchestration complexity is definitely something. And then persistent storage, how we handle data that's persistent for all the stateful applications that we're deploying within containers. Networking, I can't highlight this anymore. I keep talking about this. Making sure containers are within their own networks, network segmented, and secure networks is a critical part of deploying containers, because once you do expose your host environment and other environments to those container environments, you're creating this nightmare of potentially lateral movements in the event of a container application or a container compromise and so forth. And then security, addressing security, all of these complexities involve security. Addressing security and vulnerabilities continues to be one of the biggest things that we see when it comes to containers and container environments. We talked about best practices in previous slides, such as ensuring segmentation, running your static analysis of vulnerability management. We talked about the least access privileges and so forth and all that. So yeah. And then now the fun part. So what I'll do is when I come back, we are actually going to set up a quick Docker environment. We're going to set up a user on our machine. It's going to be a Ubuntu machine. We'll download and install Docker. We'll package an application, a simple Hello World application, or one of the applications that I've used in some of our demos before. We'll build out the Docker file. We'll package it into a Docker image, and then we'll deploy the container. And we'll show you how this works, in our live demo. So thank you and stay tuned. I'll be right back. All right, thank you and welcome back. So let's get right into our live demo. As I mentioned, what we are going to be doing in this part of the video is setting up Docker, setting up a user on our Ubuntu machine. We're going to download and install Docker. We're going to set up a simple Node application as usual, and then we're going to build out a Docker file. We'll package that into our Docker image, and then we'll deploy that as a container. So let's get right into it. One of the things, and as I do this, we'll walk through some of the security best practices that we mentioned. One of the first things that we kind of talked about was not using our root user, a highly privileged user, for running those containers and container images and so forth. So what I'm going to do is I'm going to just open up a terminal, and what we're going to do is set up a new user. That way we can use that particular user to set up Docker and all those other things and run our containers and so forth. So let's proceed with that. I'm going to create a new user. I'm going to do my user. I'll just call him my co-user, as in container user. This is asking me for my password for my current root user, and that should be fine. It's likely going to ask me for password. So let me create a password for this user. Retype that. It's going to ask me for things. I'll just say container user. Hit enter. None of those. I don't need to put any of those. Yes. And our user is added. So now we have a user called my co-user. So that's the user we're going to be using for setting up our container environment. So that said, what I do need to do now is switch to that user. So I'll just do su and my co-user. So now we're working as that user. And you notice now we can see here we're working as that user and not that root user that we had. So what I'll do is clear the screen, and I'm gonna do a simple update just so we can ensure that our package repositories are up to date. So I'll do a sudo apt update, and then my user is not. I'm supposed to modify that user. My apologies. So I created that user, but I never added him to a group. So what I'll do here is sudo. Actually, let me switch to that user. Cybersecurity. Let me switch to the root user for now. And then what I'll do is I need to add our container user to a group. So we should be back there now. What I'll do here, authentication failure. So let's do su cybersecurity. That should be good. Perfect. So we're back to our root user. What I'm going to do is add our container user to the sudoers group. So basically tell them that I want him to be an admin at least. So hit enter for that. Now I can switch back to that container user. Perfect. Awesome. Cool. So let me do that package update again. And we are good. We should be good there. What is going on here? I think my keyboard is acting weird. There you go. Cool. Perfect. So that looks like everything run. Our packages are up to date. I'll clear that. And then what I'll do is I'm going to install a few packages. What I'm doing is installing the HTTPS certificate, and then I'm going to do I'm going to try to install curl just in case it's not, and software properties common. So these are all libraries that I'm installing. So let's hit enter for that. Those should be good. And I'll put all these commands and probably like a file or link a file in the description of the video. So in case you're trying to follow along, I'll do this. That looks good. So what I did was, let me go back just to explain it. What I did was I installed a few packages. The first one was apt transport HTTPS. This allows package manager to transfer files over HTTPS. And then what I did was also install CA certificates to manage the SSL based applications. And then I installed curl just in case we didn't have that. Curl is a tool for transferring data to a server. You can essentially browse the web with it for a simple task. And then I did software properties common, which is a script that it provides software properties common, provides scripts for managing software. So that's what I did there. So I'll hit cancel there. And then the next thing I'm going to do, since I have curl installed, is I'm going to add that key, Docker key, to a list of our security certificates and keys within this server. So I did that. It says it's deprecated, but it's fine for this purposes. And then now what I'm going to do is essentially download Docker itself, and I'm going to get whatever the most stable version is. So hit enter there, hit enter. It's working in its way, it's doing its thing, and that is done as well too. So I'm going to clear that up. And now what I need to do is to add my co-user, which is the container user that I created, to the Docker group to essentially, actually wait, before I do that, I did pull the repository, the source files for Docker. What I do need to do is another update. And then what I'm going to do once that updates is clear that up, and then ideally install Docker. So let me do sudo apt install Docker, and what I'm installing is the community version. So I'm gonna hit docker CE, yes to that, and everything should run. Perfect. Give it a little bit of time. Perfect, that worked as well. Everything worked well. Clear that up. Now what I do need to do is add my co-users, which is that user over here, my container user, to the Docker group. So what I'll do is I'll just do a sudo user mod because I'm trying to modify that user, like AG, and then I'm creating a group called Docker and adding my co-user to that group. So hit enter. Oops, Docker. Go back up. That was a spelling mistake there. Docker, perfect. So I've added my co-user to the user group Docker over here. So that's what it is. Perfect. So what we've done so far is we created a new user called my co-user. One of the security things we talked about is ensuring that we're running with a non-privileged or root user. So we created this user to run those container environment. And then we downloaded the Docker files, community edition. We installed that. And then essentially what I did here is simply add that user to the Docker user group. So that's what we've done so far. We're just doing like our initial prerequisites, setting up the user and so forth, to kind of highlight the importance of the least privilege access that we talked about and so forth. Now what I'm going to do is set up a simple hello world application in Node, and that's the application that we are going to run as part of our demo when we package our application into a container and so forth. So what I'll do is I'll make a directory called my app, and I'll just navigate into that directory, and what I'll do is create an application file in there, .js, nodejs application. So what I'll just do is, since I have that kind of written somewhere because I don't want to redo that, is I will just grab that code and paste it in there. I'm just doing an echo statement to write a file, and then what I'll call that file is my app.js, and then I'll clear that, or we can verify that it exists. I'll do an ls and you can see my app exists there. And then what I'll do is just open that so we can see if it actually wrote everything the way we wanted it. Perfect. So it's in there. Perfect. And this application, just to explain it, simple application is just going to say hello world. Once we navigate to that, notice we're listed on port 3000. So we'll talk about this when we get to setting up our Docker file, what this port means in terms of exposure, some of the things that we talked about and so forth. So this is great. So that is all good. What I want to do now is create the Docker file, and then we'll take it from there. So perfect. Let me grab that as well too. Like previously, I'm just gonna paste this here so I don't have to type it out. And then actually I'm gonna call it Docker file. And then what I'll do is ls just to see that it exists. So we see Docker file here. So I'm gonna open up the file and then I'll explain kind of what we're doing there. So Docker file, perfect. Now, just to explain what we're doing in this Docker file, what we're doing here is ideally we're saying from this image, we're looking for Node version 14, which is specifying the base image that I want my package to derive from. So from Node 14 is just saying this is the Node version and base image that I wanted to derive from. Remember how we had talked about base images and so forth. So I'm building off of that base image of Node version 14. And then working directory is just saying this is the current working directory inside this container, like a command, like a CD in Linux. Any subsequent commands will be in this Docker file, will happen in this directory. And then that should actually be my app. So I'm glad we went into that since I named it my app. So I will call it my app, and then I'll come down here, copy. I'm basically copying everything that I want from like the source files into the destination folder, and then run npm install. This is where I'm actually installing Node package manager, and then copy everything. Dot is just basically saying I'm copying everything from like the contents of that source file into the destination container. And then expose 3000, I'm telling this Docker file or Docker image that what I'm going to do here is expose port 3000. This is where our application is going to run off. So once we eventually package this, you'll notice that we'll navigate to this using port 3000. Also, this highlights the importance of what we talked about earlier, as in exposing your container to your host environment. For example, we're only saying for this container we only want port 3000 open. So even externally, if we wanted to access our applications, the only way we would access it would be this exposed port. So you don't want to expose any ports that you're not going to use and so forth within your container. So we're saying we're using port 3000 here. And then the actual command that runs is once this container fires up, we're telling it that we want to run node. And then I should actually be changing that too, because I think my app is called my app instead of app. I think I used this earlier on. So my app, that would be correct. So that's what the Docker file is doing. Basically, that's a walkthrough of this. Here we're pulling version, we're specifying working directory, we're running some install, we're copying contents, we're exposing this port, and then this is the actual command we run. So I'll close that out, save that, and we are good to go. So now the next thing I'm gonna do is actually create a Docker environment based on the official Node.js image. And what I'm going to do is just grab that as well too, so I don't have to write this whole thing. I'm just going to do an echo statement. And then what I'm going to do is grab it, copy that, and paste that here, and then just hit enter, and we are cool. So we should have all these files. So now we have our package manager, package JSON file, we have a Docker file itself, and then we have my application itself, which is simply a hello world application. That said, the next thing that we are going to do is then build out the Docker container. So what I'm going to do is just run a couple of commands, and what I'm going to do is copy that as well too. Actually, I could just do that Docker build. What that means is build. We're going to build our target is my app, and then we're going to call it latest. So just to explain that as well, this is saying we're going to build this my app, and then we're going to tag it with the latest tag. So one of the things that you'll see once we build this, when we go into Docker images, we can see all the list of all our images that are running, all containers that are running, and so forth. So this is just saying I'm tagging it. This is the name of the container, and then I'm tagging it with the latest. And dot means I'm including everything in the directory. So hit enter. Oops, sudo. I should be doing sudo with that. Let's just do that. Go home and sudo, and we should be good. Perfect. So it's building out our environment, as you can see. No errors. We didn't have any issues. It's loading up, doing all this thing. And then once that's done, what I'll do is I'll actually run the Docker container, and I'll instruct it that we're looking to direct all traffic from port 3000 from any external traffic to port 3000 of that container. So everything looks good. Our container is built. I'll clear this up as well, and then I'm gonna grab that as well. Actually, I'll do Docker, and then I'll just do run, and then port. Let me just put this, and then I'll explain the command as well too. So there you go. And 3000. Oops, that's too many zeros. My app. So I'm gonna run. So this command is saying I'm running Docker. I'm gonna run it on port 3000, and I'm directing all traffic to this port. So, and that obviously our container is called my app. So that's what it basically means. It just builds and runs the Docker container for that node application that we built. So I am gonna do that now. Sudo again. There you go. So now our app is running. As you can see, it says it's running on port 3000. So this is perfect. So to test this out, I'll minimize that, and then I'll open a browser, and I'll navigate to, since this is running on localhost, you can either use localhost or 127.0.0.1, and then I'll just go to port 3000 because that's the port that our container is running our app on. So what is going on here? Let me do that. Localhost port 3000. We should see a hello world, simple hello world. Yep, there you go. So we see a simple hello world, so it means our application is working and is deployed. Notice that I didn't set up any web servers, I didn't set up Apache, none of that, all of that stuff, because we packaged everything into our container. So it's like a self-contained app running in its own sandbox and so forth. That's great. Now think of it this way: we can run multiple applications in that same manner if we wanted to. So that's it. Let me do one more thing. I want to just give you, because we did talk about security best practice for containers. One of the things we do with containers is actually ensuring that we're running vulnerability management and scanning and all that. So what I'm going to do is I'm going to run a few more, we're going to run through just a couple Docker commands just to kind of give you a sense of how this works. So I'm going to open up a new terminal. Let me just do this. Open up a new tab here for the terminal. So I'm going to run a couple of Docker commands. What I can do actually is just hit Docker and the help, and then we can see a list of all the commands that we can run. So all these are available to us: run, execute, log out, config node, things like that. There's logs and so forth. I'll run a couple of them so we can just get a hang of it. Let me do clear here. And what I'll do is, the first thing is Docker images. That actually shows you all the images that you're currently running right now on your system. So let me do sudo, don't forget to add that. And then as you can see, it gives you the repository or the container name, the tag. Remember when we set this up, we had given it a tag of latest. And then it gives you the image ID, and then how long ago it was created, and what's the size of that image. So I'm going to run a couple more commands. I'll do sudo docker, I'll do network ls, and we see the networks that we have in this Docker environment. I can do sudo docker ps-a to see all the running containers, see all of these with their container IDs and so forth. So this is good. So what I'm gonna do now is hit clear again, and I'm just gonna set up a local registry. That way we can run a vulnerability scanner on this thing. So let me grab that and then we'll take it from there. But before we do that, we do need to install Trivy, which is the application we're going to use to do our vulnerability scanning. So I'll paste that here. We grab that source file, make sure it exists. We can see it here, and I'll clear this up. And then what I'll do is install that D package. I'll do an install Trivy. And what does it complain about? Unpacking Trivy, dependency problems. So let me go back there and do, it says RPM is not installed. So I'll do sudo apt install. And I'll do fix missing just in case it needs more. RPM. It says fix broken. Okay, let's do that. Yes. So we got all our dependencies fixed there. Let's go back and do that install, see if it works. And it was good. So we got Trivy set up. That's our vulnerability scanning. Now let me proceed with setting up that local repository. The local registry, so we can actually scan the container that we have running. So let me go ahead and grab that as well too, and we'll take it from there. So Trivy is pretty much set up. I'm gonna try to run a simple one. Let's see if I do Trivy and images my app, and the tag was latest if I remember. Let's see what it does. So it's trying to run a vulnerability scan, and then I get an error here that says it's unable to initialize blah blah blah. When I tried this earlier for a different demo or lab, I believe it's because it's trying to pull from like a hub, and maybe I need to just set up a local registry for this. So let me go ahead and do that. So what I'll do is pretty much, let me grab that, paste that here, and sudo as always. So that is good. Now what I'm doing is I'm setting up a local registry. So typically it's just trying to pull because it's looking at the hub rather than actually trying to look locally, since my images are locally. So that's what I'm doing here. And then what I'm going to do is tag that container or image as a local image as well again. So I'll paste that. And what I'm doing is linking it to my local registry. So that should be done. Sudo. Good Lord, I keep forgetting that. And then now what I'm going to do is I'm going to push my image to this local repository or registry, sorry. And sudo that. And you can see it's pushing to. That should be done in a moment. All good. Just waiting for this particular one. So should be all good. There you go. And now what I can do is run Trivy against that image because it's local host now. 5,000, that's where my local image registry is. And I'm looking at folder or my app. Container my app and the latest. And now this should run with no issues. I hope so. This should run with no issues. What we're doing here is continuing to talk about the security conversations that we're having. You consistently and always need to run vulnerability management scans against your containers and so forth to keep them active from all the vulnerabilities that are out there. So let me go ahead and run that, and we should be good this time. There we go. It's downloading the newest database. It's still failing. So what am I doing here? Let's see. I pushed that to it, so that should be good, but not sure what's going on here. So let's do that. Copy that. Let's paste that again. And then I'll do sudo Trivy. Maybe that's just what it is. And there you go. So it was like, oh my god, simple, sudo. So there you go. So now you can see a list of the potential vulnerabilities with their CVEs and so forth and all of that. This is how you run, like, for testing purposes. If you wanted to do this on your own, this is how you would run like a vuln scan against your containers and stuff. So as you can see, it's just a bunch of vulnerabilities that are within the database and so forth. But when you look down here, it says we have 0 known vulnerabilities, low, medium, high. So we are good. So, and thanks for staying throughout this. I hope you enjoyed this. There's a whole lot more that we can talk about containers and container security, but hopefully this was a good introduction and high level overview for you. Stay tuned. Don't forget to hit like, share, subscribe, and I'll catch you guys next time.